Alright, so I got the instruction decoder stuff set up. We're using the 4051 3 to 8 line decoder. And since we have 16 possible instructions, we're using 2 of them, and the enable pin is going to one of these inverters. I have a spare inverter, and that's inverting it. So this is the lower 8 bits, and this is the upper. Yes. And here I have a demonstration circuit set up here as well. But I did solder this together, so in here are the 4 bits, and right now I'm just looking at the outputs. So if we could see that, yeah, the addresses are here, so we could see that it's 0. Or, well, these aren't the addresses, these are the value in the RAM at that address. So I just kind of turn the RAM on, and that gives me mostly zeros, but it does sometimes give a random value, like it was giving 2. Let's see if it'll do that again. And over here are the actual lost power. Yeah, over here are the actual connections. Right now I just have it to set up for a test, so this LED that you see that's red right now is 1, and that other one that just flashed, no, this LED is 0 that's on right now, and that LED is 2 that comes on. Yeah, that's 2. So as you can see, it goes 0, 1, 2. And another thing that I had to do is that this is an analog multiplexer to multiplexer. So that means that it's not just going to automatically provide you a 1 or a 0. You have to give it a voltage on the A pin right there. It has to be a voltage that is going to be given out or taken in. So yeah, I forgot to solder that. So what I ended up doing is I just kind of jammed a resistor in there, and that goes from the A pin to plus 5 volts. So what that does is that actually activates it so that it can be used. Yeah, so let's see it. Is it gonna do it again? No, yeah. As you can see, this is a huge mess of wires that I have right now. And I'm gonna have to solder some test circuitry just to manage all these LEDs, and these jumper wires are very loose and they come undone a lot. Also, I want a better solution for the power supply other than just pressing it together. Yeah, so that's what this circuit has right now. So just to review, we have our clock, and we have our 2 counters, the instruction counter and the program counter and the sub-instruction counter. And then this is an SR latch, which generates the timings for these 2. And then that goes down to these 2 RAMs. And these are the RAM circuitry. There's also some other stuff here, which is this over here is a given address if you want to specify an address. These are all set to ground right now. I also need to solder some jumpers here so that these are automatically set to ground. I need some pull down resistors or something there. And then the RAM has to be inverted. They go through these inverters, and then this RAM goes to these 2 decoders, which this is the instruction RAM, and then that goes to these inverters, and it goes to these decoders. Then we have this RAM, which goes down to these inverters, which is going to go to some other circuit here, which is going to be the actual RAM, and then that's also going to go back up to the program counter to implement the branch instruction. Yeah. So yeah, we have that. We also have these. These are OR gates and AND gates. Yeah. To feed in the instructions, it goes to a NOR gate and then some inverters here because we're trying to make it an OR gate. So I don't have any OR gates, so it has to go like that. Then this right here is I'm really just trying to remember myself, but this is yeah, this is kind of a weird thing. This is supposed to be my my zero detector that detects when the address is 0, so that it could go back to the programmer circuit to program the RAM again, because we've iterated through all the instructions. This circuit, this is an AND gate, which is a mistake. If you want a high detector that detects when all the bits are high, this would work for that, and that is what it does. But I really think that I need a zero detector because we have to detect it being high and then low. These counters already have a output for ripple carry stuff. That already works as a detector of the number 15. So this is redundant for that purpose. But what I do need is a zero detector that detects when it's 0. And if you want to do that, you can't just invert this. That would just give you when it's any number other than 0. So what I need to do is I need to replace this with OR gates, and I don't have any more OR gates. I had some NOR gates. As I said, this is a NOR gate and this is a NOR gate, and of course I've used them all. So that's just kind of sitting here right now. It shouldn't be crucial for the operation of the computer, but it is going to be important for the programmer. And then we also have, I guess I'll just turn it off. And then we also have this right here. This is the, as I said, this RAM is going to go out, and that's going to go to the writable RAM. As I said earlier, this RAM is not writable by the computer. It is only used to store the program. But if we want to store a value in RAM, that would go to another RAM, which I'm going to have somewhere over here. And that's going to be dictated by the output of this RAM. Well, like as I said, these outputs are for the instructions. They go to the instruction decoder here. I already have that set up. I just need to solder some more stuff there. But this stuff, it goes to these outputs, and I just have the wires for that just come out right now. Also, here's all the wires. It's kind of a mess. I need to work with that more. But the outputs of this are going to go to the writable RAM, and it's going to go to the branch instruction and other stuff. It's in the schematic. But what I need to do here is I don't want this to happen like for the branch instruction. The branch is going to change the value in RAM because the RAM is addressed by the counter, and if we're changing the value in the counter, that's going to change the value in the RAM. So because this is ahead of this, it shouldn't really be a problem. But just in case, I'm going to have some registers here, and these registers are going to make it so that when the RAM says jump, or when the instruction is to jump and it jumps, the value is going to be stored, and then it will go back up. Wait, actually, that would be on this one, I think, right? Yeah, that. Yeah, the instruction is stored here, and yeah, so that should take care of that, I think. So we should be able to work with it just as it is, I think. Yeah, because the instruction to branch is going to be specified here, and one of these is going to be high, and that's going to say branch, and then that's going to combine with something from the sub instruction counter, and then when it says branch, it's going to go back here and say load. And because this has to happen before that, then it should be fine. I need to test that though. So the first instruction this computer is going to be able to do is to branch. And that's something I'm going to have to implement soon. But the first thing that I'm going to do when I have the chance to work on this again is to get some header pins, or the female header pins. Yeah, these female header pins, and I'm going to basically just solder a bunch of LEDs. This will push in like this, and then I'll have these LEDs like this, just LEDs, and they're going to be soldered here. So and then there's going to be ground here too, so that I could see which instruction is being used without having to have this wires. Like these wires, they're very fragile, and sometimes I think that I made a mistake in soldering this and I get all confused, but really just one of these wires is loose, so that's no good. We're gonna have to have LEDs here. While we're at it, we can have some here too as well, to see what the opcode is, and then what instruction is going to be executed is going to be here. This right here is the input. This is a data input. Is it the data input? Yeah, this is the data input from the programmer. And then I have these wires right here are to stop the program counter and to clear it. So that's going to have to go here as well for the programmer. So the programmer is going to have to clear the program counter, stop it, and then it's also going to have to use this other wire here, which is the RAM write. So we're going to have to, we have these three wires, like this yellow one, like these two are to stop the program counter, to clear the program counter, specify the values here, and then write the RAM. So these three wires are going to have to go to some more header pins. And then I'm also going to have to make a programmer. I don't want to program this by hand, really. So I guess we could just say one of these Arduinos could be the programmer, and then that could be soldered on one of these boards. And then that could have one of these ribbon cables. Yeah, and the ribbon cable can go here, and then that could go off to the programmer. And then it could program the RAM to specified values. Yeah, so we're gonna have to do all that, and we're going to have to do pull down resistors on this thing. Also, the programmer is gonna need to use this thing too, because the programmer is gonna have to clear the program counter, stop the program counter, and then go through all the addresses using these while writing the RAM while writing the RAM at each address. And then this is the data input. These header pins right here are just the current address given by the program counter. And then we also have some sub-instruction counter, like so we have the program counter is these blue lines, and then these green lines are the sub-instruction counter. These are going to have to go to their own decoder too. So we're gonna have to have another one of these decoders. Yeah. So another one of these decoders is going to be used, or maybe not this one, because this is a 3x8 line decoder, and I'm out of these sockets. Like, if you could see clearly here, this one uses two 8-pin dip sockets just connected together. This was my last 16. These are all 14s. I have a lot of 14 dip pin things. But yeah, so somehow the sub-instruction counter is going to have to go to some kind of decoder, and that's going to give us 0, 1, 2, and 3. And then on 4, the program counter goes to the next address. So the sub-instruction counter is going to have to do that as well. I believe for the branch instruction, we should be able to do it without the sub-instruction counter, because we're not really moving any registers around. We're just going back up here. So yeah, that's how that's gonna work. But really, for now, all I can say is that this circuitry, as it is right now, seems to work. I have to add some pull-down resistors, and I have to have a pull-up to the A pin on these. After that, we could just make some support circuitry, and then we can implement a branch instruction. After that, we could worry about registers, the ALU, and later than that, the EEPROM as well. So that's the update for this couple of days, and I'll see you next time, which is probably not going to be that long from now, since I'm just trying to do these updates rather quickly. So thank you for watching.